All right, welcome back. This is section 12.4 on alkanes, which are acyclic saturated hydrocarbons. So just to do a quick review from the previous section, acyclic means there's no ring structure present, no ring, and saturated means single bonds only. And hydrocarbon means contains only C and H atoms. So we're going to be looking at structures that contain only carbon and hydrogen. That's a hydrocarbon. There's only single bonds between the carbon atoms, and the carbon atoms don't cycle around to make a ring structure. So the goals of the section are to know the general molecular formula for acyclic alkanes and the structural characteristics common to all alkanes. So acyclic saturated hydrocarbons are called alkanes. An alkane is a hydrocarbon that contains only single bonds. We'll talk about cycloalkanes farther along in this chapter. If it's a cyclic compound, then it gets cyclo before the word alkane. So just a note here, the A-N-E ending on alkane, this means single bonds only, which means the molecule is saturated. We don't cover chapters 13 and 14 in this class, but in chapters 13, and in particular, you would talk about alkenes and alkynes. And these are saturated hydrocarbons. That's where the alk comes from. Or sorry, these are hydrocarbons, but instead of being saturated, alkenes have a double bond. And alkynes have a triple bond between carbons. So in OChem, organic chemistry, an alkane is a hydrocarbon that has only single bonds between the carbons. It's saturated. And alkenes and alkynes are hydrocarbons that contain double or triple bonds, so they're unsaturated. And if they're cyclic, you add cyclo in front of it. So a cycloalkene would be a hydrocarbon that has a ring of carbons, and somewhere in the hydrocarbon, there's a double bond between two carbons. And a cycloalkyne would be a hydrocarbon that somewhere in the hydrocarbon has a carbon-to-carbon triple bond. And if it's cyclo, that means the carbons form a ring at some point in the compound. So just a quick advanced look at what you would see if we continued into chapter 13 in this class. But in chapter 12, we're just talking about alkanes. These are saturated hydrocarbons. They only have single bonds. Okay, so things that they have. They contain only single carbon-to-carbon bonds and carbon-to-hydrogen bonds. There's no double or triple carbon-to-carbon bonds. And acyclic saturated hydrocarbon alkanes can contain either continuous chain or branch chain carbon-carbon bonds. So because it's acyclic, that means we're not going to have any ring structures in these types of molecules. But we could have continuous chains, one chain all in a row, or we could have branch chains where you have a long chain with some branches coming off of it. So because alkanes, acyclic saturated hydrocarbon alkanes, contain only single carbon-to-carbon and carbon-to-hydrogen bonds and no rings, we can predict their general formula based on the number of carbons present in the molecule. So the general formula is for the number of carbons present, the number of carbon atoms. You can predict the number of hydrogen atoms that would need to be in that molecule, or vice versa. If you know the number of hydrogen atoms, if you knew the total number of hydrogen atoms, you could reverse this to predict the number of carbon atoms. And this works for, again, acyclic saturated hydrocarbon alkanes. So no rings and no double or triple bonds. So for example, let's say we have 5 carbon atoms, 5 C atoms, then N equals 5. And so we'd sub in a 5 here. 5 times 2 is 10 plus 2. We'd have 12 hydrogen atoms. So our formula would be C5H12. Another example, let's say we had 6 carbon atoms. So our formula would be C6, and then we could calculate how many hydrogens we need. 2 times 6 is 12, plus 2 is 14, C6H14. So from this formula, you should be able to, if you are able to identify or are given the number of carbon atoms, write out the number of hydrogen atoms and write the formula. Or if you're given a formula, you should be able to determine if this qualifies as an acyclic saturated hydrocarbon alkane. So for example, you could be given C7H16, and you could be asked, is this an acyclic saturated hydrocarbon? And you should be able to say yes, because based on this formula, if you have 7 carbons, you'd expect 16 hydrogens, and so it checks out as an acyclic saturated hydrocarbon. Okay, in the next 2 sections, we're going to talk about structural formulas, so how to draw organic compounds, and we're going to talk about 3 different ways to draw them with what are called expanded, condensed, and skeletal or line angle formulas. I'll see you then. Thanks.